Hello, this is the free fall lab that I will develop. The objectives there are the study of the motion of the falling object by gravity without applying initial velocity, in addition to the effects of air resistance on the motion, considering the velocity over the time. I performed the experiment recorded to the fall of an object and take the data from the tracker program, which got the actual data of the situation that I record. Then with the computational model, simulates using Newton's second law of speed and position of the object. Here we can see the condition for finding the weight value as a vector, as well as the air resistant force, where it is was defined as the force expressed in vector component with the coordinate y and expressed in terms of the square of the speed and a constant called v. Here from the simulation, considering the air resistance and no air resistance, I got the following graph of position versus time, where we can see that the simulation data without resistance predicts a little more than the actual data predicts of the position over time. But in calculating the value of the constant V for the drag force, I could accurately estimate the simulation with the air resistance to fit the actual data. So in this graph we can see that the actual data fits the simulation with the drag, considering the drag force. So this simulation is accurately estimate the real data with the drag force. The orange is considering the simulation without drag force. Considering the graph of velocity versus time, by plotting the speed without considering air resistance, the speed is increasing at a constant rate, which is the value of the gravity. And if I consider air resistance, we know that the velocity tends to the constant value. This value is called the terminal velocity, and this is because at the time, and this time, the gravity force is equal to the drag force produced by air resistance. So here we can see that how the velocity is changing when I'm considering the drag force, and then is getting constant for certain value. But if I not considering the drag force, we can see that the speed is increasing with a constant rate. That is the rate of the constant of gravity. In this table we can observe the effect of air resistance to reach its terminal velocity for a certain time interval. That is observed, the value of the velocity is constant, and it is the value minus 1.0529 meters per second. This is not true for the case in which ignore air resistance. We can see in this table the velocity is changing at a rate of 9.81 meters per second square. So if when considering the terminal velocity in a different case to be released at rest, we can see that if we throw the object with some speed down, considering the effect of the resistance, always reaches the same terminal speed that I get if I'm throwing from rest, regardless of the speed that is applied. So here we can see this is for the considering an initial velocity of minus 10 meters per second, and this is for minus 5 meters per second. We can see if in certain time we can see that the velocity remains constant. That is the terminal velocity, that is when the force of gravity is equal to the drag force. Thank you.